Well, hey, y'all. It is Monday, and that means it's time for a new section. So I hope you've had some success with the past two lessons on logs. I did assign all the odd problems so you could check. So hopefully you did the work and you checked, and things are going well. Um, it's a new normal, isn't it? Today, we're going to look at properties of logs. There are going to be four different properties of logs that we're going to look at, and we'll practice them today out of our book. And then on Wednesday, I'll give you another assignment in the same section. So we're going to take all week to work on properties. And the best advice I can give you on log properties is to go back and review your exponent properties, because remember, logs and exponentials are inverse functions. And so their properties work together. So let's just get started. I'll probably do 3 or 4 videos for today. And again, we'll use these this week. Monday and Wednesday, we'll have Zoom meetings on Tuesday and Thursday so we can check in and see how we're doing. And then probably Friday, we'll have a quiz. So I'll post that on Friday and I'll put it in Google Classroom. But let's go ahead and get started. Thinking about what we've done. Another thing that I will do for you is I have paper copies of my notes. There we go. Okay. I have paper copies of my notes that I will upload. I'll scan and put in Google Classroom so you can see on paper. And then also we'll do these video notes. Alrighty. So we are looking at properties. IES. I don't know what happened there. Of logs. Properties of logs. We've looked at rewriting logs and exponents. We've looked at evaluating and solving. We've looked at the definition of a logarithm that says that the log base b of x equals y if and only if b to the y equals x. That is, remember, the domain and range switch places on exponential and log functions because they are inverses. We've looked at the log property of equality, which says log base b of x equals log base b of y, then x equals y. In other words, if the logs are equal to each other and they're in the same base, then you set the arguments equal to each other and solve. All right, so properties of logs, we're going to look at 3 or 4 of them today. These are all based on exponent properties. The first one is called the product property. So we will just start with that. One, we'll say, is the product property of logs. All right, you know product means multiply. So this is the property right here, and it says if the log base b of AC, so now we have a product in the argument. Log base b of AC is equal to the log base b of A plus the log base b of C. So that's the property. And the question is, why? What the heck? Right? In other words, why is this true? Well, it's true because when I multiply terms, what do I do with my exponents? I add them on like basis. And if you remember that the log value in log form is the exponent value in exponent form. So the log of this equals what? The sum of the two pieces. Here's the flashback. Remember, if you have 3 to the 4th times 3 to the 5th, then the bases are the same. So when I multiply terms, I add exponents, 3 to the 4 plus 5, which is 3 to the 9. And the exponent in exponent form is the log value in log form. All right? So that's the why. It really, really helps you to understand this if you know your exponent rules. If your exponent rules are sketchy, then I would strongly encourage you to go back and look at them before we go much further. All right, so here is an example, and we'll do a few examples But here is my first one, and it looks like this. Log base 2 of 4x plus the log base 2 of 5 equals the log base 2 of 40. And this is what we would say is expanded because it's already written out. And so when you see this, the first thing your eyes should track for is like, okay, look, all right, everybody's in base 2. Whew, we can do this. We haven't looked at doing things that are in different bases yet. And so, like, all right, everybody's in the same base. Great. Now go back and look. What's happening on the left side? Well, I noticed that I'm adding 2 logs. What property do I know that involves adding? Oh, look, right here, the product property. When I add 2 logs, I can condense it this way. So what am I going to end up doing with the arguments of each log? Multiplying them together, right? So I can rewrite this. This is expanded. I can condense this into 1 log, log base 2 of what? Again, what does it say that I'm going to do with the arguments? Oh, look, it says I'm going to multiply them. And that is what we are going to do. So 4x times 5 is 20x. And again, what did I do? I took the argument of 4x and the argument of 5 and multiplied them together. Who says I can do this? This property up here. It's not just left to right on things that are equal. It's also right to left. If this is true, then I can condense it and rewrite it this way, which is what I did. So over here, what did I use? I used the product property of logs that says I can do that. I'm going to take this and move this up here so it doesn't get in our way. All right. Now what? Well, notice I have log base 2 of this equals log base 2 of that. Again, my bases are still the same. So, oh yeah, I remember what? Yeah, we had that property of equality for logs that says what? Log base b of x equals log base b of y, then x equals y. If I have 2 logs equal to each other and they're in the same base, then the log property of equality says that you can take the argument and set it equal to each other. Oh my goodness. So I went from insane new stuff I don't even wow to a one-step equation. Isn't that cool? So logarithms, shabam. Now we're linear. 20x equals 40. We can even do that one in our head. So we'll divide both sides and we get x equals 2. Hooray! All right, so before I finish this up, we're going to do another example because I know one example is not enough. If you need to press pause here and get all this down, go ahead. But I'm going to go ahead. I am going to go on to the next example, still using these 2 properties, right? So new page. And this is 1b. So let's see. We are log base 6 of x plus log base 6 of x plus 5 equals 2. All right, let's see what's going on. I've got logs on this side with the plus sign between them. Go back and look at your properties because we're going to be building. Eventually, we'll look at 7 different properties. Notice that their bases are both base 6. That's good. We know how to do that. I'm adding. So it looks like, since I've just looked at one property, this is a prime candidate for the product property. The product property says I can rewrite a sum as log base 6 of the product of these 2 things. Now be careful. X times x plus 5. Remember, we're distributing. I'm going to go ahead and write it down like this first before I multiply it out. Now let's distribute. X times x is x squared. X times 5 is 5x. So we have log base 6 of x squared plus 5x equals 2. Huh. All right. Now we're like, I'm stuck. All my variables in the argument. They are. I don't have any properties for this. I can't rewrite it as something else except for, wait, I remember. I can always rewrite a log as an exponent. And when your variable is in the argument, that's how you get it out. You rewrite it in exponent form. So let's do that. As my kids in the past have called this exponentiating. All right, I'll just say rewrite. Rewrite as an exponent, yes? And that's technically using the definition of a logarithm. So we would say what? Base raised to the exponent equals argument. So 6 to the second power equals x squared plus 5x. And now we're like, wait, what just happened? The logarithms are gone. And now it's a quadratic. Isn't this crazy how the functions just segue from one to the other? It's all connected. That's why you can't let go of one little piece of learning. We're not doing the new thing and letting go of the old thing. They're all interrelated. So we can simplify this and we get 36 equals x squared plus 5x. And this is a quadratic. And how do we solve quadratics? Well, we're going to try to factor. Yes, that's the most efficient way. So set it equal to 0 because factoring means finding the x-intercepts. And the x-intercepts are found when the quadratic equals 0 because that's where the x-intercept is where y equals 0. So let's keep it simpler. Let's keep the x squared positive. So that means we'll subtract 36 from both sides. 0 equals x squared plus 5x minus 36. And what are we going to do? So here we do, let's say set equal to 0, factor, and solve. So we're looking for factors of negative 36 that have a sum of 5 and 9 and negative 4. So 0 equals x minus 9. X plus 9. Woo, almost made a mistake. X minus 4. Double check. X squared minus 4 plus 9 is 5. 9 times negative 4 is negative 36. And we factored correctly. So we factored it. Now we got to solve it. So let's set each of the factors equal to 0 because that's what, if the only way that this equals 0 is if one or both of them equal 0. So we'll just use that good old zero product property. And if x plus 9 equals 0, then x equals negative 9. If x minus 4 equals 0, then x equals 4. Okay. Shoo, look at all that. Half a page. Before we go on to the next one, anytime you get a solution, you really should check it. We need to check. And the one we need to be suspect of is, of course, the negative one. So we can do it log of 4. Can I take the log of 4? Yeah. 4 plus 5 is 9. Log of 9. Can I take the log of 9? Yeah. All right. How about negative 9? Log of negative 9. Think back to last week. We had some problems like this. And I said, when you solve, you've got to check your work because remember, logarithm has a limited domain. Many of our functions have negative infinity to positive infinity domain. But remember, log, the graph of the mama function, looks like this. And the domain is what? Just greater than 0. In other words, you can't take the log of a negative number. If you have your calculator, either through Desmos or through the one that hopefully downloaded for you, please let me know if that happened. If you try to take a log of a negative number, even in base 10 or base E, you can't. You'll get this error. It'll say out of domain. Well, let me just try it right here. So I'm going to do just, well, we did this the other day. Remember? It's still up there. Log, can you see that? Log of -6. And what does it say? Error means, why are you asking me to do something that you know we can't? Because you were supposed to know the domain, right? So, all right, well, I don't like that. I'm going to try again. All right, log of, what is our answer? -9. Log of -9. Enter. Okay, this time, look what it told me. Error, non-real answer, which means what? Do you really want to go back to imaginary land? Because normal logs are complicated enough. Let's don't try to do imaginary logs. All right, so no. Not negative. Can't take the log of a negative number in the real world. So since this one won't work, remember what we do? We do like slash, and he is, remember our fancy word? Extraneous. That's an extraneous solution. So which one works? 4. All right, hang on. We got lots more fun to come. See you in a minute. Bye.